All right. Hey guys, so today we're going to be talking a little bit more about functions. Remember, functions are very important. We're going to be using them a lot in our autonomous and our skills runs. So, uh, to start, we're just going to do a pretty basic turning function. So, I've set everything up here just like you've seen when I've done it in person with you. We have void to initialize the function, name of the function, and then our parameters. Our parameters are going to be in degrees for right now. I believe you can use radians. The inertial sensor should have radians on it. So, we're going to be turning using the inertial sensor, like I just said. If you don't know what an inertial sensor is, it is a sensor that detects movement and acceleration in three directions. So it detects rotation and movement along X, Y, and Z axis, and acceleration. So the inertial sensor, it's pretty simple. I've got it set up over here. Inertial 1, we've got our 2 motor base, motor 2 and motor 3. We'll go ahead and call this left motor, and we'll call this right motor. That makes it much easier to classify them. So now, we'll head over to our function. First thing, we need to realize we are going to be using this function probably repeatedly if we're going to be using it during a skills autonomous. So robot's going to be, driving around the field. So first thing we have to do is make sure that every time we use this function, the inertial sensor is recalibrated or reset. At least the rotation needs to be reset. So we'll call it first inertial 1. Then what do we need to do? We could do calibrate, but that takes a couple seconds. We could just do either set heading or set rotation. So set rotation, 0 degrees. Easy enough. We could also do set heading. Okay, what do we do next? Well, we want this to run whenever our robot is not facing the direction we want it to. So what I would do here is use a while loop. So I would do while, and then open parentheses. I would say this up here, degrees, because if we want our robot to spin 90 degrees, but our robot is currently facing 0 degrees, we would put 90 up here when we call it. So I would do while degrees is not equal to, when you see exclamation mark equal, that means not equal to. I think we talked about that. Then we'll do inertial 1 rotation. Let's see. And then another opening brace. So, while the degree up here is not equal to the inertial's rotation measurement, we want our motors to run. So here we're turning right, so we want our left motor to spin. Think about it, robot spinning right, left motor is going to spin forward. And we can go ahead and add speed if we want to. I'll show you another method of doing this later. We'll just call it 50%. And while degree not equal to inertial run rotation, we want our right motor to spin reverse at 50%. And there we have it. Pretty simple, just a couple lines. So we have our inertial 1, we're resetting our rotation to 0 degrees. While this measurement is not equal to the inertial sensor's rotation, the left motor is going to spin forward, the right motor is going to spin reverse. You can also do this with set heading. And you could, down here, use inertial 1 heading. And that would still work just as fine. The only difference really between heading and rotation is that one of them only goes 0 to 360 and the other one goes beyond 360. It can count how many turns you've done. That's the biggest difference. So in here, we can go to autonomous. We can just delete all this. Inside our autonomous, we want our robot to go ahead and turn right. We'll say 90 degrees. Silly me. Up here we have to include functions.h. There we go. So now when I run this code during the autonomous period, the robot is going to turn right 90 degrees. Something else we could do is called a proportional loop. It's a loop that changes the speed of your motors based on how far away they are from their target. So this is some more advanced stuff, but it's pretty simple. I'll go ahead and give you an example if you want. We'll just call this p right for proportional. You can use degrees or radians, preferably radians. I'm just using degrees as an example. So I would do inertial 1, set heading, but I would also make a variable called error. And then I would do while error is not equal to 0, then run your code. So up here I've initialized error, but error does not have a value. Because it doesn't have a value, it can't equal 0, which means this while loop will automatically run. So while error is not equal to 0, now I want to set what error is defined to. So error is equal to, and we have to do this within the loop because it's going to change within the loop. So error equals our degrees where we want to be minus our inertial 1 heading. And we want to do left motor spin. We'll spin it forward at error %. And then right motor spin reverse at error %. Or you could do spin forward at negative error. Either one will work. But now we have created a proportional loop. So what this will do is this code right here, or I guess all of this, is going to spin our motors at the % speed that our error is. So in here, if instead of turn right 90, I have p right 90, my proportional right 90, oh, we have to build it. Go. This should go in just a second. There we go. So now my robot is set to 0. Right now it's at 0 degrees, and I know I need to turn right 90 degrees. So my error right now is degrees this minus my inertial heading, which is 0. So my error is 90. That's going to set my motor speed to 90%. Then, once my inertial sensor has turned, let's say 45 degrees, half of 90. When my inertial sensor is at 45 degrees, my error is 90, because my degrees, minus 45, which means at 45, my motors are going to be spinning at 45% speed. Then once my inertial sensor gets to 80 degrees, now we're only 10 degrees away, so my error is 10. The motors are spinning at 10% speed. So the motors are dropping 1% speed for every degree that I approach my destination, if that makes sense. So this, if this is a concept that you can grasp, this is something that is going to be really, really important for judging. If you get a judge that asks about your code, this right here is going to be really, really good to tell judges, because you are going beyond uh, what pretty much anyone else is doing. Um, Normally people will have an autonomous, and maybe their autonomous works, but they're not using functions. Functions are the next step that make you stand out from other teams. But when you have these functions that have, uh, you know, really fun, intricate math in them, that is what judges notice, and that will stand out. So you will probably notice that I did not do a turn left. That is for a particular reason. Turning left, making a robot turn left using this method is a lot harder than making it turn right. Or I guess it's more difficult to think about. Um, I will give you a hint though. If instead of plugging in 90 for P right and you just want your robot to turn left, you could plug in negative 90 and it will turn left. So instead of calling this turning, or instead of calling it turn right, you could just call it turn. Oh, that's already called. Okay, so we'll call it turn direction, or we'll just call it P turn. Always keep your code simple but readable. So P turn. In here, your degrees, whatever you set them to be in your code, right now it's set to 90. If I set it to negative 90, now this is going to turn left. I set it to positive 90, it's going to turn right. You could change that. You could make a function that turns left, and when you plug in a negative value, it'll turn right. It's really up to you. You could have both. Normally I use both, but if one doesn't work, you can just use one of these and plug in a negative value and it will turn the other direction. So I hope this was useful. I hope you guys start integrating some of this stuff into your code, because this is kind of big stuff. I mean, judges love to see this kind of stuff and they love to make sure that you understand it. So if you guys have any questions, contact me or ask a question in the comments or email me, whatever. And I will answer your question to the best of my ability. So I hope this makes sense, and happy coding.